Hello and good day. I hope you learned something from the part 2. And today is more exciting because we will be getting close in understanding and developing the project into a full-scale alarm monitoring and control system. First, let's map out what we need to do today. So guys, if the button is pressed and if the LED is off, it will switch on, and pressing again, the LED will be switched off. And that is how we will do to toggle an output. And in our case, we have to toggle an LED light. And to debounce an input is like eliminating the noise generated by the physical bounce of our input button when it is pressed. So guys, this is very important, otherwise you could get a wrong signal out of this noise. And for example, if the bouncing is not applied, you could accidentally get or place two orders in your online shopping, in your Amazon or in your Lazada or in the Shopee. So guys, let's do the coding. Our first data type, the constant and lead pin, which was connected to 2, and the second one is our constant and button pin, which was connected to 3. And for our void setup, we will let the Arduino know that our lead pin is an output. So pin mode, lead pin, output. And for our button pin, we have this pin mode, button pin, input, pull up, because we will be using an internal resistor of the Arduino. And what do we have in our void loop? Guys, we need to track the value of our button pin so that we could have a reference to execute an action to what we wanted in our LED, and or even to debounce our button. So we will declare it as a variable integer, and we will call it the button state new, of which value shall be read in the parameter digital read in the void loop. And we also need this to be printed in our serial monitor. So serial.print ln button state new. And of course, we need to initialize our serial monitor in the void setup. So serial.begin with a usual baud rate of 9,600. So let's move forward. Let's do the coding for our debounce. And guys, we will be using a malice function to do this thing done. And because these numbers or this time will eventually become bigger, to contain it in the integer, so we must use a data type called the unsigned long. And first, we have to declare our present time. So unsigned long present time, which is equals to millis. And to declare the previous time, which is the last time we toggle our output, we also need to have this unsigned long declared globally in previous time, which is initially equals to 0. We also have the unsigned long for our debounce timer, and we will say it's 10 milliseconds, and I think this is enough to ignore the noise. And to have our reference for our resetting of the debounce timer, let us declare this button state old is equals to 1, and we also have this variable integer, the button state current, which is equals also to 1, because I want our transition from high to low that the action will take place. So guys, here is the condition to reset our debounce timer. If the button state new is not equal to the button state old, the previous time will be equal to millis, or equals to the present time. So in this case, we have get enough time to ignore the noise and to toggle our circuit, and whatever the reading that sits there, or the button state old, which is equals to 1, is also the button state current. So if the present time minus the previous time is greater than the debounce time, so whatever the reading that has been there is assumed to be the current reading or the current value of the button. So our button state new, if our button state new is not equal to the button state current, then our button state current will be the button state new. So now our button state current is the button state new, or when the button is pressed, the button state new, the value will become the button state current. So what you will gonna do to your LED? So if the button state current is equals to 0, the button is pushed down, and if your LED or your LED is off, initially off, so we must declare it globally. If the LED state, let's call it your variable integer, and LED state is equal to 0, or if it is off or off, initially off, if LED state equals to 0, then digital write, this is what will happen to your LED, lead pin high, and we must leave a footprint that it is switched on. So lead state is equals to 1. Otherwise, how do you say otherwise in the programming world? Else, digital write, lead pin low. And again, you must code that your lead pin is off, so lead state is equals to 0. And to track our button, the button state old will now become your button state new, as it resets and returns to its cycle into the loop. Alright, let's try to upload the code. And let us check the circuit. Let's try this one. Upload. Sometimes it takes time to upload. It is sometimes good to have this thing compiled first. So right like this, button. So I have triple T's, so let's correct this one. And then I have to compile first, and button state also change to D, button state old. Then I think we're good to go. So let us compile it again. Now compilation is complete, a success. Then we will download or upload this to our microcontroller. So let's upload this one and let us check if the button is pressed, the LED will switch on. If it is off, like this, okay, it's switched on and it's switching off. Remember guys, we can do more than just switching on the light. So please watch my next video, the part 4, where we will use this kind of programming to navigate and to create the LCD menu. So please watch out for the next part of the video series, the part 4, because we will be dealing with the menu system with a single button, and as we progress it will be a multi-menu system. Thank you.